All right, welcome to the first demo of AI-900. In this one, we take a look at automated machine learning and kind of machine learning in general. So this is my account. There is some other stuff going on in here that we don't really need to worry about. But the first thing that we do need to do is create a machine learning resource, right? So let's start with that. Let's search for machine learning, and there we can see Azure Machine Learning is right here. It has this this nice logo. It's kind of a chemical lab bottle type of thingy. Anyway, we don't have anything here, so let's create a workspace. I'll put it into my existing subscription. I'll create a new resource group for us AI-900 demos. I'm going to use that one. And then the workspace name itself. This is the deepdives-eu ML workspace. We're going to put this into East US. We're going to be a new storage account will be created. A new key vault will be created. A new application insights will be created as well. And we don't need to create a container registry here. If we do use containers for model deployments, then we can create that at that point. So let's create all of this. All right, that deployment is now complete. So let's go to our resource. This is what a machine learning workspace resource really looks like. One thing that we're going to do here is we're going to use the Machine Learning Studio. You can see there's a link here to our studio. We could just also go to ml.azure.com. This is what the Azure Machine Learning Studio looks like. Let me get rid of all of the clutter here. Okay. And the one thing that we're going to do this time is we're going to do some automated machine learning, right? So this is available here on the left-hand side, automated ML under authoring. Click on that. And then we can click on new automated machine learning job. And then we set it up, yeah? So our job name could be this one. It's okay. We have a specific experiment name here. Let's call it MS Learn Bike Rental, because that's the data set that we're doing. Automated machine learning for bike rental prediction. Cool. Next. So now we need to select what type of task this machine learning problem would be. And where the data comes from. So in our case, this is actually a regression problem. So we try to predict the number of rentals. And then we have some data. So let's create a data set here. It's historical bike rental data. And it's of type table. You can see that there are different values available here. For our current API, we want to use the ML table data type. Then the data source, we're going to see in a minute. It's actually going to be from a local file. We're going to upload it in a minute. And then the destination should be blob storage in the storage account that was just created. That's this workspace blob store. That's perfect. All right. Next. So now we should upload it. Now the actual data set, the URL is in the instructions. It's aka.ms/bike-rentals. And then we can see that there's a zip file getting downloaded. Now there are 2 files in here. Now we're going to need ML table and then dailybikeshare.csv. So let's upload that folder. Now you can see that both of these files were uploaded. Let's click on next. And everything seems to be okay. So let's create this one. Cool, so the data set has been created. Now we can continue with our task. So task type was a regression. The data set is this bike rentals data set. Cool, so the target column, so which column contains the value that we want to predict, is rentals. It's this one. You see that it has already taken in the data set. Here, we could even look at it quickly here. Then, with regards to additional configuration settings, the primary metric here is normalized root mean squared error. We're happy with that. There would be other possibilities as well. We don't need explanations. So if you take a look at the info here, you can see that this would be an explainability report. So we don't need that. We don't need stacking. And we don't want to use all models. We're actually just going to select a couple, for cost reasons. So here are the different models. And we want to use light GBM and random forest. So just 2 for this demo. There is of course a cost and time, aspect here for this demo. All right, then limits. So max trials, we just want to do 3 trials, and we allow them all to be concurrent. We want to use a maximum of 3 nodes simultaneously. A score threshold. So this is the kind of score that we're happy with. We want to stop training at this point. Let's say it's 0.085. And then the timeouts could be like 15. Oops. 15 minutes. And we want to enable early termination. So if the model sees that there is no more progress being done, we're not getting better results, then we can stop the task. We want to do a train validation split here. There are different options for validation. And we're going to keep the validation data being 10%. That seems to be okay for us. We don't have a separate test data set. Then for compute, we could either select instances or a cluster or serverless. We're going to go with serverless. We don't need a GPU for our purposes. I'm happy with the CPU-based instance. I'm going to go with dedicated here. The low priority would be an option, but then it could take a while until that's going to be running. So let's not do that. And we're happy with the standard DS3 B2 option here. Just need 1 instance. Right, so next, let's submit the training job, and that will then also start it. And this is going to take a while, so I'm going to speed up the recording so that we'll get back here once it has finished. So see you in a minute. All right, we can see the status is completed. It did take about 10 minutes, a little bit more, for it to run through. It's okay. So now under this overview, we can see that there is this best model summary over here in the bottom right hand side. So the algorithm that won was the voting ensemble, and it even gives us some details. So the weights that were created for the ensemble here are here. It's great. Other stuff we could take a look at. The error that was the outcome was 0.88. Sorry, 0.088. Not too bad. We have the other metrics here as well that give us, maybe a little bit more information. So here are the different models that were used. So the voting ensemble was clearly the best one out of these. Right. So next, all we want to do is deploy. Right. So if you go to our model, this was the winning one. We select that. Now we can deploy this over here. We want to deploy it to a real-time endpoint. Okay, here is the number of instances. For high availability, we should have a minimum of 3. We're going to create a new standard DS3. Yeah, it doesn't have enough of that. Oh, that's good. Well, we could just take this one as well. E2SV3. We need a new endpoint. Let's use this one. This one should be unique. We use the default deployment name here as well. We don't want data collection. We could enable it here. And we don't need model packaging either. So let's deploy this. It's going to take a couple of minutes. So now that the model deployment has started, we can go over to endpoints here. And here is our endpoint. And we can see currently that it is provisioning. All right, so now the endpoint has been deployed. So it seems to be running. Okay, so our environment is deployed. Here you can see all of the settings and everything. And then there's a tab here called test that we can use to test, as the name suggests, right? So let's do that. And we need to put in some input. Here is the data structure. And then we want to input data as follows. Sorry, I'm trying to copy paste it from the instructions. Here we go. Yeah. So an array inside an array, or a list inside a list in JSON. with the actual values in it. And then we can run test. And then we'll get some results. And the result here is 345. So based on this data, which includes information like the temperature, humidity, and so on, in this particular day, it will suggest or predict that we're going to have 345 bike rentals. Right. So that's everything for us. If you are running this in your own environment, then consider deleting the endpoint, right? So we can go on the left-hand side to endpoints and then select it and click on delete. This is the only thing that really consumes money from your account. You can keep the machine learning workspace. That doesn't really cost anything except for some storage costs. So that should be okay. All right. Thanks for listening and see you in your next demo. Till then.